Hey there once again, YouTube. My name is Benjamin Robert Ferriello. Yes, that's my full name, but I go by Ben, and I'm an amateur seismologist who would love to make a career out of monitoring volcanic and tectonic hazard areas, though I'm a little bit more interested in volcanic activity itself. Just a heads up, I may talk a little fast in this video. You know, I do in pretty much all my videos. I'll try my best not to, but there is a lot of information I need to get out and a very little time to do it, so just bear with me and just listen closely. Now remember, I have been doing actual analysis for about 6 months now, and I've been studying volcanoes for probably about a year, so I do still have a lot to learn. However, I have already learned a lot. I'm not in school yet, but one of my goals is to join the University of Washington hopefully by the end of this year. If you don't already know, I have my own website at https://monitorsize.weebly.com, and there is a link to it in the description box below right under my email address. It contains a great deal of information, including how easy it is to do what I do, how to find seismic data, how to discover new seismic programs, how to use those programs, and much more. I even have 2 seismic events menus, which contains hundreds of seismic plots, images, and examples for many different seismic events, including the 2008-2009 dike intrusion of Yellowstone Lake, the 2018 Kilauea eruption, several recent events at Yellowstone, and much more. So go check that out if you wish. My website is still being added to, and I'm currently working on another section for the seismic events menu, so it'll grow and grow and grow forever pretty much. So there has been some interesting activity as of late. I am going to try my best to keep this video short since I do have some other work I need to get done. Now, on New Year's Eve of 2018, December 31st, there was a very energetic swarm just west of the northern tip of Yellowstone Lake. Now, I have this swarm in the seismic events drop-down menu under Yellowstone Supervolcano, and I also did a video on it, so check the recent videos in my channel. About a week later, a very powerful but short swarm struck just to the northeast, of Yellowstone Lake. It was very odd, and I also completed a seismic events post for this event too, even making a separate video about it. The past few months, Yellowstone seems to be changing. Yesterday, there were 2 weird events that I really want to talk about. One is obviously a surface event, but it appeared on seismic stations many miles away. However, that is not the weirdest thing. You will see that in just a second. Also, I just quickly want to show the recent rapid-fire swarm that occurred at West Thumb Lake on January 10th, 2019. It was very short, but the events occurred in such rapid succession that they blended together to create an emergent, tremor-like event. Remember, emergent means that it's slowly built instead of striking immediately. I will get to that, but first I want to talk about the strange surface event at Yellowstone. It definitely seems like a surface event, but is extremely, and I mean extremely, weird and peculiar. Check this out. So here's station YMC at Maple Creek. Now here, let me pin this down real quick. This is for the 10th. And for your UTC, here's the 9th, and you can see the UTC time code right here, 00 for the 10th. Let's go down right before midnight. Mountain time. See this dot right here at the bottom? And unless you're monitoring this area closely like I do, you would have completely missed this little guy right here. Now this event right here is this event right here. Notice I have YMC up for the same day as well. Downward gliding frequencies, which I thought was very weird, but I will analyze that in just a minute. So again, I pulled up the data for station YMC and 5 other stations. This event right here is small, right? Barely noticeable, really. But it's very, very peculiar. I noticed that right off the bat. Now, again, let me put on the spectrogram just real quick. Now, I will analyze this further in just a second, but look at this. Let's look at the waveforms real quick. What the hell? Now, if this only occurred at one station, I would definitely say this is normal surface activity. However, this specific event did not just appear on YMC. You can see the little dot right there. The little tiny dot right at the end, that is the event. Did not just appear on YMC. You can see it on YNR. You can see it on YML, just barely. So this mysterious event was felt on seismic stations YHL, YMC, YMR, YNR, and YML, and occurred around 6:35 UTC, January 10th, 2019, which is also 11:35 p.m. Mountain Time, January 9th, 2019, just before midnight on Mountain Time. I also want to point out that this mysterious event seems to be coming from the surface. Not only does it not appear on any of the boreholes whatsoever, and it appears on YNR, and borehole 950 is right at YNR, but it didn't show it. But not only is it not showing on the boreholes whatsoever, it looks like station YHH up here and other stations in the area down here near YWB and YDC did not feel it at all. It took a very specific path from YHL to YMC to YMR to YNR and down to YML and then disappears off the seismograms. So if this was coming from underground, it appeared on YHL right here and even YML down here, it should have appeared on all surrounding stations if it traveled this far. This proves that this event was above the surface. It was not seismic in nature. However, ask yourself this: what the hell type of surface event could cause such a vibration? Please keep that in mind as we check out the following data. I don't know what this was, but it definitely was not a truck, not a car, not any mode of transportation I can come up with. It also was not wind or construction, that's for damn sure. So what the hell could this be? Something that is even creepier is that this event traveled around 558 miles per hour. Yes, you heard that right. 558 miles per hour. It had to have, according to the data, which you'll see in just a second. So let's check it out real quick. Was this a UFO or a supersonic jet? Personally, no explanation makes any sense to me right now, even the supersonic jet idea, seeing that a sonic boom being felt over 31 miles away would have surely been detected on the other stations up here and down here. Definitely would have. If it traveled from YHL to YML, and it was like, let's say, one sonic boom throughout the whole area, it would have been felt on other stations down here and up here as well. So why didn't it? So I don't think this was even a sonic boom. So what the hell caused this thing? Let's check this out. Here we are in the seismic program waves. Here is the strange event right here. I have selected the likely P wave arrival times for this peculiar surface event. Notice it starts near YHL. Then near, which is near the northwest boundary of Yellowstone National Park, by the way. And then it travels from YHL to YMC. And then to YMR in Madison River. Then it traveled to YNR in Norris, and then heads south towards YML. And YML is south of YNR, which means that's a different direction, guys. That shows an obvious change in direction. And these were the only stations that saw this event, except for borehole 950. Notice borehole 950 did not show whatsoever at all. Borehole 950 is right at Norris. This seismogram right here, this station, YNR, borehole 950 is right near it, but a few hundred feet underground, I believe. So if this was seismic in nature, it would have appeared on borehole 950 as well, but it did not at all. So this really intrigued me, guys. Let's real quick match the P wave arrival time of YHL, the first station at Yellowstone to detect this event, and YML, the last station to detect this event. Now I cannot do it on both the seismograms, so I'm just going to have to do it like this. Here, let's go all the way over here. See this line that I just generated? Notice how it pierces right to the P wave arrival. So here's the start of the event when it started at YHL. Here's the start of the event when it was seen on YML. The first station that was detected at and the last station. And let's just do S wave. So that's 199 seconds. So let's even it out and say 200. Let's say that's 200 seconds. Now it says the time difference is 200 seconds. So from here, the start of the event on YHL, to right here, in this time frame right here, is about 200 seconds. So that means once it was seen on YHL, it took 200 seconds to reach YML. Now here on Google Earth, I have the exact locations for YHL right here and YML right here down to the exact latitude and longitude. Notice, let me open this, I have the ruler tool ready and handy to go. Okay, let's check this out. Right at the center of YHL right here. Let's go. Wow, I can't believe it did not do that. Okay, let's try that again. There we go. Go right down here to the exact point. 31.5 miles. So let's just round down because of the craziness. Usually you should round up, but I'm just going to round down. So let's just say 31 miles, okay? So we just discovered that from YHL to YML is about 31 miles. I found this interesting, seeing that it took only 200 seconds, in other words, 3 minutes and 20 seconds, to reach YML from YHL. So remember this, 3 minutes and 20 seconds across an area of 31 miles. Keep that in mind. So here we are at pace calculator, which is also a speed calculator. So remember, in 200 seconds, this vibration traveled 31 miles. Now, that would be really slow if it was a seismic event, but we already discovered it is coming from above the surface. Was not seismic in nature. But check this out. So, 31 miles. YHL to YML is 31 miles. Again, 200 seconds, which is 3 minutes and 20 seconds. So, why don't we do 3 minutes and 20 seconds? And how far did it travel? Remember, 31 miles. So did we do that right? 200 seconds, which is 3 minutes and 20 seconds. 31 miles. Yes, let's calculate. Drum roll, please. What is it going to be? Boom, here we are. So that would be 6.45 seconds per mile, or 4 seconds per kilometer, which is also 558 miles per hour, or 898 kilometers per hour. Wow. Or almost 15,000 meters per minute, or almost 250 meters per second. Just think of that. 250 meters per second. Wow. That's very fast, guys. Why? What? What? How is this even possible? Now, I know this thing probably did not travel in exactly a straight line, seeing that it seemed to dip south once it reached Norris. You notice that on the seismographs? But it kind of went in a weird pattern. It did not go in a straight line, but still, regardless, this should be impossible. It says 558 miles per hour. What? So this surface event at Yellowstone traveled around 558 miles per hour. Even shifting direction? What in the hell was this thing? Definitely was not a truck or a helicopter or low-flying jet or anything I can think of. I don't think you're even allowed to fly that low and that fast. It would literally have to be a supersonic jet near the surface of the ground. I mean, it literally showed on seismic stations. Usually jets flying by at that speed never appear on seismic stations, ever. It really did shake the ground, guys. So again, I ask, what in the hell was this? Also, again, if this were a sonic boom or a reverberation trail from a sonic jet, why did it not show on the other stations? If you know what the heck this could be, please let me know below. 558 miles per hour is extremely peculiar. So if this is incorrect, however it appears the math does check out, please let me know. Now let's real quick look at all the stations that detected this event. Here we are in the seismic program Swarm. We're going to very quickly take a look at this strange surface event. Let's do a high pass 0.7 hertz filter just to get those microseisms out of the way. Let's go down to 634. Yep, here it is right here. This is the event right here. The strange surface event that traveled 558 miles per hour. I want you to keep something in mind as we go through these stations. Notice the downwards gliding frequencies. Notice that it looks a little different in each station, but you will see this same pattern. It starts at around maybe 10 to 15 hertz or so, and then goes all the way down to about 2.6 hertz. So there it is right there on YHL, the first station that detected this event. Let's go to the second station that detected this event, which was YMC. Let's turn persistent rescale off. Here it is right here. Now let me zoom in. Remember, this traveled at 558 miles per hour. Notice when it started, it was between about 10 to 15 hertz and glides all the way down, this time reaching about 3.6 hertz instead of 2.6 hertz like the last station. But again, we see the same exact pattern and the same exact event on YMC. Let's go back. Let's go to the next station to feel this event. Let's turn persist to rescale off and do a 0.7 hertz high pass filter since this is a broadband station. And let's go to 6:35-ish. Here is the event right here. Let me zoom out. This is the surface event that traveled 558 miles per hour. Notice it doesn't really look like it here much, but you can kind of tell the frequencies did glide downwards just a little bit. But this is still the same event. This is not a coincidence that this popped up at near the same time, and pretty much at the perfect time too. I mean, look right here. There's YHL, YMC, and YMR, which is what we're looking at. It shows right where it should. So again, it did not really show that many or that much downward gliding frequencies like we saw on some of the other stations, but it still is obviously the same event. Let's go to the next station to feel this event, which is YNR at Norris. Again, this is a broadband station, so I am going to add a 0.7 hertz high pass filter. Let's go to 6:35 something or other. Here is the event that traveled 558 miles per hour. You will notice, kind of looks like the frequencies were gliding downwards here, but it seemed to change with distance. It seemed to change a little bit with distance, but we already know this is one event. This is something that was traveling. I don't know what. Definitely was not a car or a truck, but it traveled from point A to point B in a very short amount of time, spanning a very large distance. I mean, 31 miles. It takes a while to drive 31 miles, guys, even at 60 miles per hour. I mean, that's just, it wouldn't, there's no way it'll take you 3 minutes to go 31 miles. That's pretty fast. But again, we see the same event here. And let's go to borehole 950, which is where YNR is. And let's go to the same exact time. It should show at the same exact time because it's right near YNR. But as we see, it does not. And it did not show on the borehole. Borehole 950 did not show, meaning that's one of the reasons, just one of them, why this is a surface event. Let's turn persist to rescale off. This is not a broadband station, so we do not have to add a filter. Downwards gliding frequencies. Notice that once again. Showing that this event was real. It really did happen because it showed up on multiple seismic stations. Again, going from point A to point B, about 31 miles in 200 seconds, which is 3 minutes and 20 seconds. Notice the frequencies start in between 10 to 15 hertz. Gliding downwards, right here is about 9.1 hertz. Right here is about 7.068 hertz. Right here is about 5.3 hertz, and then it levels off at about 4.2 hertz. But yeah, downwards gliding. Look at that. Just like on YMC. Look at that. Does that not look similar or what? Look at that. Here, I'll try to put them a little closer. Look at that. Yeah, that's definitely the same event that we saw. And plus, the seismic program Waves pretty much proves it's the same exact event. Whatever this was, went from YHL. And all these stations are in order, too, from northwest to southeast. Very interesting, guys. Very, very interesting. Let's go back. Again, here's YML, the last station in the park to feel this surface event. Whatever it may be, I have no idea. Here's the in-depth waveforms real quick. And I think it starts right about here. Ends right about there. Yeah, very weird event, guys. Very, very odd. So wasn't that weird? How is this even possible? Also notice how each station detected this event with high frequencies and then the frequencies dropped with time. And once again, I must say, what the hell? Something really must have been moving at a very fast speed and a low altitude just before midnight on January 9th, 2019, going into the 10th. So I think I may have caught this on the Old Faithful webcam. Before I start, this recording was not done by me. This is the Old Faithful webcam archive. You may say, Ben, there's an Old Faithful webcam archive? What? Yes, guys, there is. I will leave a link to this channel in the description box below. It's actually pretty cool. The Geyser Observation and Study Association keeps a complete archive of the live stream from the Old Faithful webcam in the Upper Geyser Basin. So let's see if we see anything. Before I play the video, you are looking towards the northwest, which is the direction that this strange event started at. And remember, you can obviously not see the patch of land that contains YHL, but YHL is in that area right up there, towards that direction right there. So if we see anything that could be connected to it, it would come from this direction and head southeast, which would show the object slightly coming towards us. Like, it would look like this. It would come from here probably and go like that direction, where it's slightly getting closer to us. So, and remember, the event occurred at 6:35 UTC on January 10th, which is 11:35 Mountain Time on the 9th. You can see the date and the time on the bottom, which is in Mountain Time Zone. So if we see anything, we should see it around the 23:35 mark. Here it says 23:29, about 5 minutes or so before this happened. I'm going to play it just a few times, and let me know if you see anything in the sky coming from this direction, heading this way slightly towards us. So keep your eye right in this direction, right here. I don't know if this is what caused the ground to shake, but the direction that this object travels and the time correlation suggests to me it is likely this object caused the ground to shake. But then again, it couldn't. But then again, why? It seems pretty high up there, guys, and the camera doesn't even shake, it seems. Well, it's nighttime. It'd be kind of hard to see the camera shake at night sometimes, unless it shook really hard. But still, I don't know if this is connected, but I still thought it was very interesting. Let's play the video real quick. Here it comes. Keep your eye right up there, remember. And there it is, right there. You see that? I'm going to play it one more time. Let me go back. Whoa, way too far back. There we go. Remember, keep your eye right up there. There it is. What is that thing, guys? Same direction and same time as the vibration that traveled 558 miles per hour and showed up on multiple surrounding stations. There it is, right there. What is that? What the heck? It looks like a normal plane, right? It's traveling the same direction. Doesn't look like it's traveling 558 miles per hour, though, because a few minutes goes by with it in the sky. So I'm still very confused as to what this could be. I've zoomed in just a little bit. Let me go forward. There we go, and here it comes right now. There it is, and it looks like it left a streak behind it. Notice that? Look, right when it starts, it looks like there's a little streak behind it, right? Like a normal contrail or chemtrail or something, you know. Looks like, yeah, I don't know what this was. Could this have caused the vibration, guys? Could this have caused it? I don't know. So what was this thing, guys? Was this really the object that created a surface vibration that traveled around 558 miles per hour? I don't know. And this event will continue to creep me out. So please go to the channel I linked in the description box below to show your support of the Geyser Observation and Study Association. Their webcam archive has not missed 1 second, at least to the best of my knowledge, so they really have a lot of footage of the Old Faithful Geyser and the Upper Geyser Basin area. Now let's move on from this craziness and quickly look at the seismic data for the recent rapid-fire swarm at West Thumb Lake. If you know me, then you know these are some of the most interesting swarms to me. They have been increasing exponentially, and rapid-fire events at West Thumb Lake and Yellowstone occurred more in 2018 than any other year on record. Now here I have stationed YLT's data for the time period of the rapid-fire swarm. Remember, YLT resides around the northern tip of West Thumb Lake. Remember, West Thumb Lake is on the western portion of Yellowstone Lake and is actually connected to Yellowstone Lake. This event was minor compared to the other rapid-fire swarms that we have seen in past few months, but it did happen and I just can't not report it, right? So here I am. The events within this swarm occurred at such a rapid pace that this event appeared to be more of an emergent tremor-like event, which can occur if multiple events occur in such rapid succession that you can barely tell them apart. And this is typical rapid-fire activity for West Thumb Lake. However, as I said earlier, these events have been increasing exponentially, with 2018 seeing probably almost 4 times more rapid-fire swarms than any other year on record, with some of the swarms containing hundreds of events within just a few hours. Will 2019 be the same? I bet it will. It is my personal theory some of these rapid-fire events are being aggravated by magma pushing additional hydrothermal fluids up to the surface, therefore creating the possibility that sometime in the future a new geyser or hydrothermal feature could appear near West Thumb. That is just my theory right now. So let's check out the data. According to the P-wave arrivals on surrounding stations, it appears this swarm occurred directly under the central portion of West Thumb Lake, or right around that area. There were around 14 events within only a maximum of about 4 minutes, with the largest part of the swarm being equivalent to about a magnitude 0.8 earthquake or so. So again, it wasn't anywhere close to the rapid-fire swarms that we have seen lately, but is still worth mentioning. It also started at 2015 UTC, January 10th, 2019, which is also 1:15 p.m. Mountain Time, same date. Now I'm going to pan this down just real quick. Remember, I'm showing it in YLT. Just prior, there was a low-frequency tremor. Yes, there was. This was not surface noise, because we go to borehole 944 at the same exact time. 20:01:30, 20:01:30. Let's go back. 20:01:30. Notice that? Look at that. Here's YLT. Here's borehole 944. Let's go back to YLT. This is the same time period. Here's YLT for the spectrogram. Borehole 944 for the spectrogram. Let's go back. Yes, this is a low-frequency tremor. I do not think water can cause this low of a frequency. I may be wrong, but I do not believe water caused this. So, unless that's a distant earthquake, but to me, let's check the dominant frequencies real quick. What am I doing? I can't believe I haven't even checked this yet. Let's go back, log power off. Let's see, these are from the background noise, so ignore those two spikes. They have to do with the background activity that is currently taking place. Look, I'll show you real quick. See these lines right here below 10 and above 5, these two lines? For some reason, they're doing something at the lake, guys. I don't know what the hell they're doing. They could be drilling, I don't know, but it's definitely caused by humans. It's definitely not natural because it's too specific. Let's log power off. Notice it stays below 3.4 hertz. So this is definitely a low frequency tremor. Starts at about 1.7 hertz. Definitely low frequency tremor, guys. Oh yeah, right before the swarm. Now, let's jump to the swarm. I'm going to go through it just with the spectrogram real quick. Notice it looks like very tiny events slowly build and build and build and build and build, merging together and happening in such a small time frame within probably, I'm going to say maybe, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe no more than 10. No more than 9 or 10 events happening in about 40 seconds. That's why it looks like an emergent tremor-like event, because there are so many events occurring at one time. See, like this, that's one weird-looking earthquake, but still. And look at that, multiple events, and it slowly dies down. Let's zoom out real quick and look at the whole swarm. Here's the very quick swarm. Very short burst, very small burst too. Let's look at the dominant frequencies of the entire swarm. Log power off. Dominant frequencies between, let's see here, between 4 hertz and 3.5 hertz. So it is not a low frequency swarm, but it was preceded by a low frequency tremor. Very weak though. Remember, this is probably, I think the strongest event, maybe it's like a magnitude 0.8, very small. We see another possible low frequency event right here. Let's go back. Let's look at the waveforms real quick. Let's zoom all the way in. And notice how it slowly builds. Notice that? See that? Look at that. 1, 2, 3. It looks like 3 separate events, each one larger than the last. And it builds and builds and then slowly goes away. And then builds again. And then builds, and then slowly goes away. And then there's a few more earthquakes at the end. With mid-range frequencies, multiple events, around 14 events maximum, happening within about 4 minutes, excuse me. So, very interesting. It was very minor, but it did occur. Another one. And I am guessing another one will probably happen in the next week and a half, I'm guessing. Because now they don't carry a specific schedule, but they do seem to carry some sort of rhythm. Some months we don't see rapid-fire swarms of West Thumb Lake, other months we do. So it's kind of all just up in the air, and I don't know what they're doing here. Again, notice that specific frequency range in the background. And look at this. I don't know what the hell they're doing, guys. I really don't understand. Look at this. See, okay, let's go to the spectra. The dominant frequencies. There's one spike here at about 5.3 hertz. Notice, look at the helicorder. Notice this bold line appears, but before it, it's not really like that at all. Well, let's go down here. Boom, much different. Now let's go down to where the swarm, or not where the swarm, excuse me, where this vibration or whatever was not occurring. Notice it changed. Boom, boom, boom. It changed. So these two right here are being caused by whatever started right here. And this is what we see right here. What is that? What is that, guys? Weird things. Look, this isn't, they're not earthquakes. They're not tremor. They're not really shown on other stations. What are these? Are these electrical malfunctions? But they have real waveforms, though. Usually electrical malfunctions don't really carry their own random waveforms. This looks like a real event to me, but I've never seen anything like it in my life. And then I don't know. I don't know. Let's log power on real quick. Look back here. Notice, look between 10 and 5 right here. Notice you do not see two lines. As we go forward, we see a spike, a spike. Those are the spikes I just showed. And then, boom. Whoops, sorry. Let's try that again. And then, boom. There are those two lines right there. See? To me, I believe that is caused by humans. I do not know what we are doing down there. If anybody's drilling into the caldera and they're listening to this, please stop. I don't think it's a good idea to start poking around supervolcanoes, guys. So once more, we did have a swarm at West Thumb Lake, very minor. Only about 14 events within 4 minutes, but it did occur. Keep an eye out for more swarms, because they could appear at any time. Could uplift be starting back up again? Maybe. We'll have to wait and see. However, the 2018 New Year's Eve swarm, and the swarm that occurred just a week after that, proves to me something really is changing under the infamous caldera. Subsidence has been occurring for a while now, of course with a few spurts in uplift, and we are currently sitting at the level last shown in 2007. More than a decade ago, guys. To me, that shows uplift will start again soon, possibly in the next few months if my theories are correct. Real quick, guys, please come check out my recent post if you're interested in the recent magnitude 3.7 in Mississippi and the magnitude 3.8 near the state of Maine. I show the data and some quick information, so check that out if you want. You can find this by going to my website, and a link is in the description box below, right under my email address. I will also post a link to this article itself in the description box as well. Also, guys, Steamboat Geyser in Norris erupted a few days after 2019 started, but it has not erupted yet. If it keeps the near weekly schedule, it should erupt either tonight or tomorrow morning. However, each of the past 5 or so eruptions have been incrementally smaller than the last, showing this super geyser may be dying off for another period of rest, or it is simply stabilizing at a normal level to continue eruptions into the foreseeable future. We will have to wait and see. So I hope you guys enjoyed this video. It truly was amazing to me to be able to analyze the data of the most peculiar surface event of all surface events. We also caught this possible object or whatever that shook the caldera on the Old Faithful webcam. The bright object was obviously traveling in the same direction at the same time, but could they be related? Also, we saw that West Thumb Lake suffered another rapid-fire swarm. However, it was not that large and most likely occurred underneath the central portion of West Thumb Lake. It didn't go much farther than that, but I believe a larger swarm is still approaching for Yellowstone. Activity lately has been weird and has been much different than the normal seismicity we usually see. Could this signal a new round of uplift could be starting? I don't know, but as you know already, I will keep an eye on it closely. If anything changes, I will let you know. Have a great day, and God bless, and remember the truth is considered hate or fear to those who hate or fear the truth. Ben Ferriolo signing off.